All right, here we go. Today we're going to talk about rotations. And so far we've talked about translations, reflections, and today we're talking about rotations. And so that's when you take an object and you rotate it about a point. Okay? And so they give you some definitions here on your first slide. And it tells you that a rotation of x degrees about a point Q, which is going to be called the center of rotation. So the point that you're going to rotate around is called your center of rotation. And it says it's a transformation with these two properties. One, the image is itself, that is, however the image starts, it's going to stay the same. It doesn't change, it's just moving location. And this time when it moves, instead of moving vertically and horizontally, it's moving circularly. Okay? Around a point. And the second part says for any other point V, then the line QV prime would be equal to the line QV. And you can see that here. The distance from the center of rotation is going to be the same. Okay? From your pre-image point to your new image point, the distance from the center of rotation will stay the same.
Got it.
At the bottom there, it says the number of degrees a figure rotates is called an angle of rotation. That should be pretty easy. And usually they'll give you the angle of rotation and ask you to draw the new image. A rotation about a point is a rigid motion. What does rigid motion mean again?
The shape of it. Oh, sorry.
Doesn't matter. Go ahead.
Distance and angles stay the same.
Yeah, the shape doesn't change at all. The distance, the sides, and the angles all stay the same. That's what rigid motion is. That's going to be important to remember for your quiz. And at the bottom it says you write the x degrees rotation of triangle UVW about a point as this. And so we use capital R for reflection. They use little r for rotation. The first number is the degrees. The second number is the point at which it rotates. And sometimes they'll put an O there when you're doing coordinate rotation, and that O means origin. So 0, 0 is your point of rotation, just in case I forget when we get to that point. So that's the notation down below. Little r is rotation, capital R is reflection.
But it doesn't matter like no, it's almost the music.
Okay, here, the key concept here is rotation in a coordinate plane. And there are some common angle rotations that are pretty easy, and these are all on here. So like this first one in the top left, it says you're rotating 90 degrees from O, the origin. And so you've got one point, it's G, and it's at 2, 3, right? If we're going to go 90 degrees from there, this line going from 0 up to G, I'll use the cursor so you can see it on the video. This line here and this line here have to be what? If it's 90 degrees? Perpendicular, right? So if you look at this, the slope here is going to be rise over run 1, 2, 3 over 2. Everybody see that? The slope is 3 over 2. So if we're doing a 90-degree angle, what should the slope be of the new point? It should be negative 2 over 3. You change the sign and flip it. So when we go from here, negative 2 over 3, since we're doing 90 degrees, we'll go up 2 and then left 3. That'll give us negative 2/3. Up 2 and left 3. Okay? So remember how to find perpendicular slopes. Flip the sign, or change the sign, and then flip the fraction. That's 90 degrees. 180 degrees is a little bit easier to work with because it's a straight line. So all you have to do is, if you went up 3 and over 2, then you would go down 3 and left 2 to stay on the same line. Okay, the slope would have to be what? If it's 180 degrees, the slope would have to be the same. It has to be on the same line. It's got to be linear because 180 degrees is the same line. So you move it the same distance away from the origin when you've got 180 degrees. That shouldn't be too difficult when you have a point. This third one, 270 degrees. 270 degrees is just 90 degrees the other direction, right? If you go 180 degrees and then you go 90 more, you're at 270. So you know how up here, when we went 90 degrees, we went up 2 and left 3 because we needed negative 2/3 to be our slope. Down here, negative 2/3 is still our slope, but instead of going up and over to make it 90 degrees, we would go down 2 and to the right 3 so that the whole angle around would be 180 plus 90 more. Same slope. That's going to take a little bit getting used to, but if you have a protractor, you can always use your protractor to do this as well, and I'll show you that in a second. And then 360 degrees just puts you right back in the same spot. So that should be the easiest one. Okay, so now you need to copy each figure in point P and draw the image of each figure for the given rotation about P. We're not going to copy it, it's up on the board. And so what I need to do is I need to take this shape and I need to rotate it 60 degrees. Okay? Around point P. And so doing that, what you're going to need is you're going to need a protractor. Okay? And this is things is going to get a little bit crazy. Let's see. So we'll take the protractor and we'll put it on P, and you can see that they're lined up. And then what we need to do is we need to move the angle 60 degrees. So right now I'm going to be changing where C's location is. So I can take this guy and I can move it to 60 degrees. Okay? Now, what I would have to do is also get a ruler out to measure that distance. Okay? Some of your protractors have a ruler built into them, so you can measure it.
Can we just measure it from the outside of the protractor?
Yeah, you can do that if you want to. So what I would have to do, because mine doesn't have the measurements on the bottom, most of yours have the measurements on the bottom of your protractors, right? Doesn't it have like a little ruler on the bottom, the flat edge? I don't have that. I could get a ruler out, right, and measure it if I wanted to. Here. Oh, I gotta move it. Okay. And you're going to see this is going to get really long, so I don't know if I necessarily want to do that. But you can see here, if I match this up, I've got about 3.5 centimeters. Okay, you see it's right here, 3.5 centimeters. And so what I would have to do is I would have to take that, and then on this 60-degree line, I would have to measure it out at 3.5 centimeters so that I could get that line. Let's see if I can move this to 60 degrees. Or it's not going to work. Okay. So if I take this and I put it out here and I measure it to 3.5 centimeters, except for this is the hard part. This is why we're not going to spend a lot of time doing this on the smartboard, because this is going to take a long time. Okay, and I'll move the ruler down so that 3.5 centimeters is on point P. Then we can mark where our new point C is going to be. Now we have to do this for every single point. So I'm going to do the first one, I'm going to do a measurement, and then the next ones I'm going to do kind of an approximation based on the distance using these lines on the protractor. Okay? But if I was making a new C, my new C would be right there. Okay? Which is not letting me stay on that point. So let's see if we can see where we got it. Okay. Pretty good. All right. So I'm going to get rid of the ruler, and now I'm just going to use approximations, but you guys will be able to use your ruler and you'll be fine. Okay? So that is my new C prime. And then I have to keep on going around and doing that for all of them at 60 degrees. Okay? This is going to take me a lot longer than it's going to take you, just because this thing is kind of crazy, right? It's just hard to manipulate. Yeah, that's right, exactly right. So you notice that I have my marker still on 60 degrees. What I'm going to do is I'm just going to look at D and say D looks like it's pretty close to the end of that dark inner circle. See what I'm saying? And so I'm going to approximate that out. 60 degrees is right here. So I'm going to say that my D prime is somewhere right about, well, let me write. What will we write on there?
I was right the first time.
I have no idea. It just worked for me. Okay, but you get the idea. With your protractor, you'll be in good shape to be able to write some things. This one's not letting me mark, so I don't know why it's not letting me mark. Okay. D prime. Okay. From here, what you could do is you can measure now your 90 degrees and measure your side. You don't really need the protractor anymore. Okay. If you wanted to, you can use the corner of a piece of paper, or if you had, you could use, like, I have a square, you know, and I can measure out 90 degrees. And so I can measure what this distance is from B to C. and I could go ahead and draw my rectangle. Okay, so it looks like it's complicated just because it's kind of awkward using the board, but really when you measure them out, you should be in good shape. I'd measure the sides of BC, figure out what their lengths are. I'd get a square and measure this corner, make sure it's 90 degrees, and then from there, I would go ahead and draw my
Beautiful.
rectangle. This would be A prime and B prime. Okay? So use your protractor to measure the distance and measure the angle from the point of rotation. You're moving everything 60 degrees down. Really, once you find the two, if it's a shape that's a 90-degree corner shape like a square or a rectangle, once you find those two bottom points, then you can just do right angle from that. Actually, you really only need 1 point moved, right? Can't you do a 90-degree angle from C now and just measure the distance from C to D? You see what I'm saying? So we can use the protractor to find C. After we find C, we can draw a line to D that's going to be a right angle. It would be best to probably do 2. It'll be a little bit easier to find 2 points from P, and then you can draw the other 2 just by making sure that you have 90-degree angles. Now on number 2, you're going 90 degrees, right? So really, do we need a protractor for that?
No.
Well, probably not, because what you could probably use is like a piece of paper,
Your brain.
okay? Well, you can use your brain too. But you can use a ruler or a piece of paper. I would use a ruler maybe. And if you stick the ruler up there on the board, which I'll do, but you won't be able to see on the video, that's fine. Because you know it's only going 90 degrees, right? So if I could get this to where the ruler would be on the bottom, and it's already got B directly above P, what I could do is I could go ahead and measure how far away that is. So we got what, 1, 2, 3, 4, is that what it is? 1, 2, 3, 4, 5. It's 5 inches away. Is that right? Try to get, yeah, maybe 4 and a half. Looks like 4 and a half there, right? Maybe 5. Let's say it's about 5. Okay? So since I have a ruler, I know that the ruler is going to have a flat bottom edge. You can mark off a 90-degree angle from that, and then go straight across that about 5 inches. And so what we would do is mark our B point at the end of that. So we would say that right about there. Okay? Would be where B is, or B prime. Okay? And then from there we can do the rest of the triangle. And so if we measure from A to B, measuring from A to B, we have about almost 6. And since my pen is ginormous, it doesn't matter here. Okay? That would be A prime at the end of that.
You gotta find the C prime.
Right? And then it's a right triangle.
So you go.
So you can measure the distance from B to C, which is 3 inches. And then you can just go down 3 inches. Make sure you have a right angle. Use your protractor.
Yeah, it'll be on the other side.
And it would be the other direction, yes. And that's where I was drawing, but I put my thumb on the board. So that's kind of neat to know that you can do that. I don't know how I did that. I put my hand here, my thumb here, and now it's erasing.
The other side of the triangle, though.
Yeah, it's going up. It's going up. I know, I put my thumb on the board.
No, it
Oh,
would be
this-
it would be by
See,
B.
Oh, yeah, I see what you're saying. Oh, yeah, you're exactly right. I'm sorry. I was like, what are we talking about now? I know it's going up. Yeah, you're right. It's going up here, and then here. Okay, 90-degree move. I don't know what I'm doing with this rule on the board, but I like the fact that you can do that. Oh, no, it didn't work at all.
You're gonna hit them at the same time.
Is that what it was?
Yeah.
I don't know. I just know I do a big old line. And now you got 2 prime marks there. And then this would be C prime. So 90 degrees is a little bit easier to work with. Okay? Just move everything down. You can measure it out. Okay, but I would still use your protractor. Protractor's nice. You stick it up there, measure the distance. You get it at 90 degrees, and you can draw your lines from there. Okay? So that's how we would do that. Next. All right, so on this problem here, they're telling you point O is in the center of a regular hexagon. B, C, D, E, F, G. They want you to find the image of the given point or segment for the given rotation. So they give you a bunch of rotations here, or they give you 6 of them, okay? And they want you to go 120 degrees from F, and then find out where F prime would be. And so that's what we're going to do. So first of all, you have a regular hexagon. Does anybody remember what all the angles are in all of these things? If you look at this point O in the center, right? If I took all these angles in the center by O, what would they have to add up to? It's got to add up to 360, right? You've got 1, 2, 3, 4, 5, 6 of them, so they all have to be 60 degrees. Does everybody agree with that? Okay, so if we're rotating 120 degrees around O and we start at F, from F to E, that would be how many degrees? 60. From E to D, it would be 60 more, which would be 120. So, it says find the image of the given point or segment for the given rotation. Where would that be? Where would we now be? We would be at D. Okay, does that make sense? Okay, so then all the rest of this should make perfect sense then too. If we're doing a 180 degree rotation from B, where will we end up? E. Right? If you're doing a 300 degree rotation for BG, the whole entire line, BG, which is this outside line, okay, so if I move it down to here, that would be 60, 120, are we getting this? 180, what would this be? Not really, not yet. 240, 300, so it would be CB or BC. It doesn't matter which way you do it. Actually, it does matter which way you do it. It would be so yeah, CB, because you're rotating around that counterclockwise direction. If you got 360 degrees for CD, it would be what? CD. You're in the same spot. If you do 60 degrees from E, you would be at D. If you do 240 degrees from FE, you would go 1, 2, 3, how many times around? 4. So you'd be at BG. That makes sense? So it's nice when you have a regular shape because all it does, if that O is in the middle, it just keeps saying the same shape, just rotating around itself, okay? If we're doing it in terms of 60 degree segments. Now if it does 30 degrees, it kind of splits everything in half when you rotate it around, okay? Which just means that F would be straight down and C would be straight up, and it just kind of shifted it a little bit. It's 30 degrees, cutting it all in half. So that regular hexagon thing, it's important to know that. But if they give you a point in the center, you know that all the angles in the center always have to add up to be 360 degrees. So if you get a shape that's not a hexagon, you have more than 6 angles in the middle, you take all those angles, divide it into 360, and that'll tell you how much each one's going to be. If it is a regular shape, which is going to be what it's going to be. Okay. On this, you need to graph triangle ABC, and they give you the points. So let's put the points on there first. You've got, this is really hard to see, isn't it? 2, 2. Right here, that's going to be A. Then you've got 3, -2, which would be right here. That's going to be B, A, B. And you've got -1, 3.
Why do we run on this?
C. It's important stuff. And you get a triangle. You guys might need to check that because my X and Y are not so thick that it's hard to see. It looks right to me. ABC. Everybody good with that? I guess I could use the black marker. Here's my,
It's just graphing.
here's the Y, and here's the X. Okay? Now, all you're doing is moving everything 90 degrees. Okay? So, if A, you went up 2 and over 2, the slope is 1, right? So instead of going up 2 and over 2, we're going to go up 2 and where? Left 2, right? And the slope got to be -1. So if we go up 2 and left 2, right here would be your A prime.
Wait, why do you have to do that?
You have to have, if it's 90 degrees, it's got to be perpendicular lines. So if the slope of A from the origin is up 2 over 2, up to right 2, then we have to go up to left 2 to make it our 90-degree angle. Okay? And then we can do B. B, we went down 2 and right 1, 2, 3. So negative 2/3 is our slope. Right? We need it to be what? We need it to be 3 over 2, right? But are we going to go up 3 and over 2, or are we going to go down 3 and left 2?
Would it be up 3 right 2?
Down,
No,
down,
it'd be
down.
down.
Not if you want it to be, you want it to be up 3 this way?
Yeah.
If you go up 3 over 2, is that going to be 90 degrees from this? So where would you have to go? If you know your slope has to be a positive 3 over 2, you only have 2 directions you go. Up 3 and right 2, or down 3 and left 2.
Can't you not go down 220?
Not from, or now are you going from B now?
Isn't that what we're doing?
That's what I'm asking you.
I don't know.
You're forming the angle from B to the origin to your next point. Right? So from B to the origin to the next point,
I think it's up
are you bringing it over here 90 degrees? I'm asking you. I'm not saying you're wrong. I'm asking you which way you're supposed to do it.
I think it's up 3 right 2.
Yeah, no.
Okay, so you want to go up 1, 2, 3, and right 2 and be right here,
Yeah.
and make this B prime. Okay? And then what's C? What's the slope of C?
3 negative
3 over negative 1, so it's 3 over negative 1, so what do you need to make it into?
1. Down 3 left
1,
1 over 3.
okay? So which way are you going to go?
Isn't it down 3 left?
What?
This is, no. Look, slope is up 1, 2, 3, and over 1, so that's negative 3 slope, right? So you need to make it a
Oh.
positive 1/3. Are you moving it this direction, or are you moving it this direction?
Left.
So you're going this way, 1, 2, 3, right here? And you're going to make this your C prime. And so does this look like you took the shape and rotated it 90 degrees? Yeah. It takes a while to get used to. Once you get used to it, it's not bad. Okay? That's 90 degrees. 180 degrees is a little bit easier. Okay? 180 degrees, I'll make the lines again real quick. Here's your Y. Here's your X. You can actually see it. Okay, so you got A is at 2, 2. B was at 3, negative 2. And C was at negative 1, 3. Okay? There, and there. Okay? And now what we're doing is rotating it all 180 degrees. Okay? So it's got to be on the same slope, right? Same line. We're just going the opposite direction. So since for A, we went up 2 and right 2, now we're going to go where?
Down.
Down 2 and left 2. Okay, that's A prime. Okay? For B, since we went down 2 and right 3, we're going to go up 2 and left 3. Right? And for C, since we went up 3 and left 1, we're going to go down 3 and right 1. So they would all be on the same line if we drew them out. And that's 180 degrees. Which looks like a reflection, right? Okay, because we rotated around the center, so we just moved it all the way around. Okay? The last one is 270 degrees. Okay? What you're going to do is you're going to do the same thing you did with the first one, except for instead of going counterclockwise, you're going to go clockwise. Right? 270 degrees is the same thing as going 90 degrees clockwise. Right? And so we're going to do the same kind of thing. So if we get these points again, 2, 2, there's your A. You've got 3, negative 2 is your B. Negative 1, there's your C. Here's your original triangle. Okay? So now, instead of going Counterclockwise 90, we're going to go clockwise 90 because that's the same thing as 270. So when we did these points over here on the first one, number 13, all we're going to do is go the opposite direction. So you really don't have to do a whole lot of extra work. You see how when we did A, we went up 2 and left 2? You see that for A? Prime. So instead of going up 2 and left 2, we're going to do what? Down 2, right 2. Okay? It would be on the same slope as A prime, but the opposite direction. So instead of up 2, left 2, we're going to go down 2, right 2. So here's where A prime would be now. Okay? For our new B, we went up 1, 2, 3, and over 2. So instead of going up 3 and right 2, we're going to go what? And left 2. That's your B prime. And for C, we went down 1 and left 3. So now we're going to go up 1 and right 3. That's C prime. And so now we rotated it 270 degrees. Okay? And you can use your protractor to check it. It might be easier at first. But using the grid, it's not too difficult when you're doing 90s, 180s, 270s, and 360s as a joke because you would just write the same exact thing over again. Right? So that's all you have to do here. We could have gone all the way around 270, but just remember that 270 degrees is 90 degrees clockwise. So you just flip things around.